Hello everyone, I'm going to help you kind of get through this percent of change section on the Khan Academy assignments that you guys have been doing. And I'm going to start you guys off with these percent increase and percent decrease equations. And you might remember that we went over these in class, but just to kind of refresh your memory, percent increase is, these equations are essentially the same, but percent increase obviously has a plus because we're adding an increase of a percent, and a decrease is going to be minus. So essentially those equations are the same except for that one distinction there. But a percent increase is going to be applicable, it's going to apply to things like taxes or tips, things like that, or just any type of percent increase. I know that's a little redundant, but it could be called a markup. Or if it just states, the percent went up, it increased in size, or it's now 30% greater. Look for those kind of key words that tell you that the percent is going up rather than going down. And then percent decrease, kind of just look for the antonyms of those words. But there's not as many. Percent decrease is definitely going to apply to discounts. And it's going to apply to markdowns, which are basically the same thing, or any type of percent decrease. Anything that states it's going down. It might say there's 30% less people or 30% fewer people sick this week than last week, or it might say there's a 1% decrease in pay versus one job and the other, something like that. Okay, so just kind of look out for those words. Look for words like less, or it goes down, or it's fewer, something like that. And then just kind of also to refresh your memory about the equation, the B stands for the base. And remember, the base is essentially just the whole. It's just what the whole is. And you remember, we've also talked about this as well. But the base is think of that as like, what was the number before the change? What was it before the change? What was the height of the flower before, it grew a few inches? What was your pay before your raise? What was the bill before taxes or tip was added? So that's like your before number, but that's your whole. Okay. And then, now this is just essentially 1, but I always write it as 1.00 because ultimately we're going to have to add a decimal to it. So when you deal with a percent, you must change that or convert, I want to use the word convert, to a decimal. So that is how you kind of want to handle that one. So convert that to a decimal. So for instance, if it's, 65%, you're going to write that as 6,500, 0.65. If it's 175%, you're going to write that as 1 in 7,500, it's 1.75. If it's 3%, I forgot the percent sign on that other number. If it's 3%, then it's going to be 0.03. Those are kind of good things to remember. And then the P, right there, that stands for the part. Okay, and just like with the base represents the before. Therefore, the part is the number after. Think of that as what happened after taxes were increased, after the taxes were added to the bill, after the tip was added to the bill, after the markup was added to the price of the shoes. But that's your after. So it's kind of like, B for before. I know P does not have, after does not start with a P, but, B for before, base, and then P for part, and that's the after. So before and after. And it kind of works that way too in your equation. The B is first, and then the part is last, which is kind of sequentially how things go. And then just kind of pay attention to the fact that this is a minus sign right there. But everything else is essentially the same with a percent decrease. That's your base. That's your percent. This is your part. All those things are still the way they were before. Okay, now to the first example here, for example 1, you will notice that, first thing you want to do is actually read the problem. That is actually kind of an important step. So it says Ray's pumpkin has or had a mass of 8.4 kilograms, kg is kilograms, before she carved it. After carving it, the pumpkin had a mass of 3.36 kilograms. So what was the percent decrease in mass of the pumpkin? Now, one thing that I've, if you remember kind of how I teach things, it's kind of a good idea to write out the equation, just a plain old equation, just with nothing put in, just so that you can kind of see how everything is laid out. So base times, and then in parentheses, 1.0, and then I'm going to use the decrease equation, so I'm going to put a minus the percent, and then that's going to equal the part. Okay, so now the base in this problem is, remember, that's the whole, that's the before, and this actually literally has the word before right next to it. So 8.4 kilograms before, so I'm going to write that as 8.4. And then this 1.00 is not affected by anything. It's just always going to be a 1 minus. And then if you look at this problem, there's no percent. It is missing the percent for sure. All right, so that means we don't know what the percent is. So we're going to put n. That's the unknown in this problem. The part we do know. The part is 3.36. All right, so now, going back to looking back at the whole thing now, I'm going to first draw my attention towards the parentheses, which, typically in a math problem, we do parentheses first, where whatever's inside parentheses, we do that first. But we can't do that. We cannot do 1 minus n. There's nothing you can do there. So that doesn't mean just give up. It just means that we have to do this a different way, which means we better distribute the number that's in front of the parentheses. And we're going to solve this very much like an equation. So I'm going to do 8.4 times 1, which is 8.4, and then 8.4 times negative n, which is going to be negative 8.4 n. And that's going to be equal to 3.36. So those things just kind of drop down. All right, now the next step is, we have a two-step equation here. We have a two-step equation, and you want to undo things the right way. All right, so the thing you want to kind of remember here is, I know there's subtraction there, but that's really negative 8.4n, if you look at that right there, but that you don't want to touch that first, because the only way to get rid of the 8.4n is to divide. So the first thing that you want to do is subtract 8.4 from both sides. Now those cancel each other out. And then I'm going to put my work over here because there's not a lot of room. So I'm going to write negative 8.4n, because that's what's left on this side of the equation. 8.4n equals now 3.36 minus 8.4. And that's going to be negative when you end up working that out. So don't get too concerned about how that comes out, but that comes out to negative 5.04, 5 4 hundredths. And remember, whenever you guys are dealing with equations, I know some of you hate showing work and writing your work, but it's just something that is inevitable in math, that you kind of want to do that. So just rewrite the problem every step along the way. Otherwise, things get really lost. All right, and then the next step, this is a two-step equation. So our first step was subtracting 8.4 from both sides. And the last step is to undo multiplication or division. So this particular problem has multiplication, and we're going to undo that by dividing. So what we do to one side, we do to the other. These cancel each other out. What do they turn into? Yep, that's right, they turn into 1, which is essentially just 1n, right? And 1n is just n. If you want to put a 1 in front of it, go ahead. There's nothing wrong with that, but it doesn't need to be shown. And then the last step is going to be dividing. And then kind of keep in mind here too, I know there's a lot going on in these problems, but just slow and steady wins the race sometimes. You got a negative divided by negative right there. Okay, so what's a negative divided by negative? A negative divided by a negative is a positive. So don't even worry about the negatives now. We know that the answer is going to be positive. So now it's just a matter of just doing 5.04. 5.04, and you want to divide that by 8.4. So then when you put all that in, you get 0.6. Now I'm using my calculator. You guys can use your calculators for sure on this as well. And then we're not yet through with this. The thing that we have to kind of keep in mind here is that we're looking for the percent. The percent was the missing part in this problem. That is not a percent, that's a decimal. So we need to change that back into a percent by moving the decimal over 2 places. Okay, so then you can just put a 0 right there. So the answer is 60%. So there was the decrease of that pumpkin. You know, when you carved it all out and decorated it and took all the guts out of it, it's now 60%. It lost 60% of its mass, I should say. So that's what's going on there. Okay, on example 2, one thing I noticed too on the Khan Academy problems that they kind of just throw in a problem that is a straightforward percent equation problem. It's not a percent increase, it's not a percent decrease type problem. It's just a percent equation. And remember, the percent equation is base, right? Let's do it like this, sorry. Let's do percent times the base will equal the part, because that's the way I taught it to you. So the percent times the base equals the part. Okay? So like I said, this one doesn't really involve an increase of percent or a decrease of percent. It's just what's the percent of the number. You know, we're just kind of looking at it in that way. So it says Finn has a goal of getting at least 20% of his grams of carbs each day from whole grains. Today, he ate 320 grams of carbohydrates and 64 grams were from whole grains. Did Finn meet his goal? So let's look at this. We've got the percent right there. Now, percent is neither the base nor the part. It's just, remember, like I said, it's just the percent. The percent is its own thing. It doesn't really belong to the base or the part. It's just a ratio. Today, we're looking at this problem. It says he ate 320 grams. Now, what does that sound like to you? Does that sound like the base, like the whole? Or does that sound like the part, part of what he ate? So I would say that is the base, that's the whole. Don't always, I think some of you, remember in class, some of you are like, oh, that's a bigger number. So the bigger number is always the base, and that's not always true, because if it was a percent increase or something, the part actually will be bigger. But in this case, we're safe to kind of go with that. All right, so let's kind of set all this up. So we've got 20%, and I'm going to go ahead and just change that to a decimal right away. So 0.2 or 0.20, 20 hundredths or 2 tenths. And then you're going to multiply that by the base, which was 320. And then, now this one's a little tricky. It says he wants to get at least, this is a little nitpicky, I guess, but at least, if you remember from inequalities, that means greater than or equal to. So greater than or equal to, he wants more than that or equal to that in terms of his whole grains, or the percent of the grams from carbs. And then you want that to be greater than or equal to 64. All right, so this looks like it's already solved, but what we want to do is this question is just asking us, did Finn meet his goal? And so this question is just asking us to confirm, is this going to work? Is Finn's diet of carbs versus whole grains working out? So just multiply 0.2 times 320, and you'll notice you get 64. So 64, and I'm going to write down greater than or equal to 64. And that is a true statement right there. So you can say yes, the answer is yes. And why did he meet his goal? Well, so he ate exactly what he needed. It's cutting it close, but sometimes when you're dealing with foods, you're not always going to be, getting an abundance of what you need. So yes, he had exactly what he needed. He needed 64 or more, and he got it. So if the answer came out to like 75, that would have been okay too. If the answer came out to 80 or 100 or 300, that would have been fine. If the answer came out to 63, let's say the answer, we had a 63 right here, then you could say, well, no, Finn did not meet his goal. He was under the amount because he wants greater than 64 and he had 63. So 63 is, even though it's pretty close, it's not close, it's not equal to. All right, in this next problem, let's read this first. It says, example 3, in a video game, Luke scored 10% fewer points than Han. Han scored 1,080 points. How many points did Luke score? So this sounds like a percent increase or percent decrease. And we're going to kind of look at the way this is worded. This says 10% fewer. That sounds like a decrease to me. So we're going to use the percent decrease equation when we set all this up. So we're going to do base, percent. Oops, sorry, not that, not percent. Percent. You want to do 1 minus the percent equals the part. So in this question right here, the base is the whole, and 1,080 is the base. Now it says 10% fewer, right? I'm going to cover that up a little bit. Is that 10? Yeah, that's 10. And then you want to put 0.10 there. Because remember, you always want to change a percent to a decimal when you're putting it into the equation or whatever format you're using. And then you want to make that equal to the part. Now the part is the part that we don't know. That's going to be Luke's score. Okay, so now let's go ahead and start solving this. And you'll notice here, if we zero in on the parentheses, we've got 1 minus 0.1. And you can actually work that out. Those are like terms. You can subtract those. So that comes out to 0.9. So I'm going to rewrite it. So I've got 1,080 times 0.9. If you want to put a 0 there, that's fine too. But 0.9 or 0.90, that will equal the part. So stick those numbers in your calculator, 1,080 times 0.9 or 9/10, and then you get 972 equals P. So there it is. So Luke's score was 972 points. And that's it. That's Luke's score. And that seems to make sense because it says Luke scored 10% fewer points than Han. Now, 10% is not a lot. That's not a ton of points lower. So his score should have been kind of close. And 972 is not that far away from 1,080. And it is smaller. And everything kind of checks out there. Now, in this problem right here, it says Kylo had 80 iris blooms last year. I made a mistake here. I think this should actually be 80. Sorry about that. So that should be 80. And this year he had 45%. He had 45% more iris blooms. So the kind of language that is being used there is indicating that this is a percent. Is that a percent decrease or increase? Yeah, and if you guessed increase, you're right. It's a percent increase because it says 45% more. The key word there is more. It's going up. So we're going to use the percent increase formula, or equation, I should say. So base times This is always 1. I always write 1.00. Plus, since it's an increase, the percent, equals the part. And back to the wording of this problem, it says Kylo had 80 blooms last year, 80 iris blooms last year. That sounds like a before figure. He had 80 blooms before. That can very well be stated like that. So 80 sounds like the whole. It's the base. And I'm going to write down 80 times and then parentheses 1.00 plus the percent increase. The percent increase was 45%. Now don't forget to change that to a decimal and then make that equal to the part, because the part is the unknown in this problem. The part is what we're solving for. And just like on the previous problem, we can go ahead and just do that part. 1 plus 0.45. So that's easy math right there. You got 1.45. And now it's just a matter of just doing 80 times 1.45. And I got 116 equals P. And that is how many blooms there were. So there was 116 iris blooms this year. Now onto the last example here, example 5. It says a brand of cereal had 2.4 milligrams of iron per serving. Then they changed the recipe so that they had 1.92 milligrams of iron per serving. What was the percent of increase in iron? And I just noticed there's a typo again in this one. Sorry, that it went down. It went from 2.4 to 1.92. So it actually should say decrease. Sorry about that. I'll make sure your copy has those changes because I haven't uploaded the PDFs yet. But we've got, so right here we're looking at a percent decrease. So I'm going to use the decrease equation. So base times 1 minus the percent will equal the part. So we're going to set all this up. Now it says it had 2.4 milligrams of iron. Now that sounds like it's indicating that's a before figure. So it's 2.4 there. And then you're going to do 1.00 because that's always what that is. We don't know what the percent is, so we'll just use n or whatever letter you guys choose. And then make that equal to the part. Now the part in this case is the after. It's the 1.92 right there. When you look at the parentheses here, there's nothing that can be worked out within the parentheses, so we have to use distributive property. Now, distributive property comes in handy, especially when you cannot put like terms together within the parentheses. So 2.4 times 1 is 2.4. 2.4 times negative n is minus 2.4 n. And that will equal 1.92. All right, now it's going to come down to solving it. So I know there's a lot of 2.4s in this one, but I want to undo this part first, because in order to undo this, we would have to divide. If I want to undo this, I have to subtract, because the opposite of 2.4 is minus 2.4. I want that to go away on that side of the equation. All right, so those cancel each other out. And then remember, you want to rewrite your equation. So we got 2.4 n equals, and then I forgot to put the minus sign there. So you want to do 1.92 minus 2.4. And don't get too worried. That's a negative, and that's okay. But you got negative 48 hundredths, negative 0.48. And now we've transformed it into a one-step equation. Now in order to solve that one-step equation, we're going to divide. And remember, always divide by the number that's next to the letter, that's attached to the letter. So we're going to divide both sides by negative 2.4. These cancel out. They turn into 1. So we're just left with n. And then use your calculator for this, and this, I think we talked about this earlier, but we have a negative divided by negative. So that should come out to be a positive when we're all done. So don't even worry about the negatives right now. Just do 0.48 divided by 2.4. It should come out as a nice, neat decimal. You got 0.2, all right? And then you have to convert to a percent. So just convert it to a percent by moving over the decimal 2 places. So move it over 2 places. So there you have it. So that was a 20% decrease. 20% decrease. That's what we got there. And that does it for your notes. Okay, so that is it. I will go ahead and post this video, and please let me know if you have any questions or you're confused about anything I did. And I would go ahead and try that section. Most of you, if not all of you, need to work on that section on Khan Academy again. It seems like most of you have low scores or no scores at all because you just didn't do it because it was so confusing. But I think after doing these together, it probably helps. And I would highly recommend going, well, not highly recommend, you must go back to Khan Academy and log in. Go back to that section on percent of change, percent problems. I forget exactly what it was called. But do those problems and work those out, and let's see some better scores. I want to see you guys. And I made these problems very much the same, very similar to the Khan Academy problems. So if you have your notes handy, if you have this all written down, use them. Have them at your side so that you can pull them out and know what to do for every problem. Okay. Also, the notes that I put online, it's okay if you don't print them out. I don't expect you guys to use all your printer ink for printing all your copies for every teacher you guys have during this e-learning period that we have. So if you just want to write these out on a piece of paper and just kind of copy them like you're copying notes from me or something, that's fine. You don't have to, print all these out and use all your paper and use all your ink. So that's up to you. All right. So that does it for these notes. Everyone have a great day. I'll keep you guys updated on what's going on next, and keep paying attention to your email and your Google Classroom. All right. Everyone have a great day. Bye-bye.